Let's look now at the nervous system, the peripheral nervous system and the central nervous system. The nervous system, as I've just mentioned, is divided into the central nervous system and the peripheral nervous system. And the central nervous system very simply consists of the brain and the spinal cord. But the peripheral nervous system is a bit more complex because it comprises the autonomic nervous system and the somatic nervous system, and the autonomic nervous system, also called the visceral nervous system, is divided into the parasympathetic nervous system and the sympathetic nervous system, and we'll look at these in a bit more detail. But first of all, let's just look at the structure of a typical neuron. It has four main components: the dendrites, which are specialized for the reception of stimuli; the cell body, which is the trophic or metabolic center of the neuron; the axon, the single axon, which transmits information from the dendrites to the next order cell or neuron; and the terminal arborizations, which make contact with a second order cell or neuron. And additionally, one shouldn't forget the axon hillock, which is a part of the cell where a decision is made whether to transmit or not transmit a neural impulse. And just quickly, the different types of nerves that are found in the body. The most common type of nerves are the multipolar neurons, in which there are a number of dendrites coming out of the perikaryon or cell body, and a single axon also exiting the cell body. These multipolar neurons can be very complex, can have very complex dendritic fields, which of course increase the receptive field of the neuron from which that neuron can gather information. Bipolar neurons have a single dendrite entering the cell body and a single axon leaving the cell body, and of course these may branch. And bipolar neurons are relatively uncommon. They're found in the ear and the eye and in the nose. And finally, unipolar neurons, in which there is a single process leaving the cell body, and this single process then splits into two processes, one of which goes to the periphery and the other goes to the spinal cord, to the central nervous system. But what is unusual is that both of these processes have the morphology of axons. They're both myelinated, but on one end, the peripheral end of this type of neuron, the axon terminals are specialized for the reception of information. We're not going to study synapses here in this course because that is such a vast and specialized topic, but you should know that there are three major types of synapses: synapses between the axon and a cell body, an axosomatic synapse; synapses between axons and dendrites, and these occur through a little spine on the dendrite called a dendritic spine; and synapses between axons and other axons called axo-axonic synapses. All of these synapses are of course chemical synapses involving neurotransmitters of one kind or another. There are a few examples of electrical synapses in the body as well.